were talking about coordinate geometry, yes, we will have a couple of graphs to draw again today. But we're moving out of the graph zone though, right? So coordinate geometry, just as a little recap, we saw that when we have an equation with one unknown, we could solve it and you'll just basically get one answer. But when we have an equation that have more than one unknown, you have an x and a y, right? So you have two unknowns in this equation. We can't solve this equation, but we can find a range of values. So you see how we have the x and the y here. X and y is equal to x plus 3. I could say, well, you know what, when x is 0, we could find out what y is. When x is 1, I could find out what y is. And I saw that this will give me a range of values going straight to infinity. Negative infinity too. You could put negative numbers there as x as well, right? And with these, what we call ordered pairs, I could write these ordered pairs as coordinates using this system of a bracket x comma y bracket. So I just write the 0 and the 3 as a coordinate. You have the x first and then the y. Please get that right. Right? A lot of the times when a student watch this, plenty of the times they don't realize the first one is just the x and the second one is just the y. That's all that it is. So if you take x is 3 and put it into this equation, you will get the output y is 6. That is all that this is. We saw that we could take these points and plot it on a graph and we get a line. Yeah. And of course, you don't need a whole set of points to plot a line. You just need 2 points to plot a line. And so it's just 2 points we need to plot any line. What are we plotting the line on? We're plotting the line on something called a Cartesian plane. That is just 2 number lines. You have a number line, the horizontal number line here, and that is for the x values. So we call it the x-axis. And we have this vertical number line here that is for the y values. We call it the y-axis. So you can see this is an example of the full Cartesian plane where you have 0, 0 in the middle. That is the origin, right? This here are the negative and the positive values of x. So you can see here that the negative values are on this side of 0, the positive values are on this side of 0. Similarly, the positive values of y are above the 0 and the negative values of y are below the 0. So you have positive and negative number lines here. And it all depends on the equation that you are drawing. So it depends on the equation that you are drawing, how would you want to draw your number lines? How would you want to draw your axes? Yeah. Do you need negative space in the first place? And we saw many examples here where we did need negative space. So we have an example here of the simplest line, and this is the line y is equal to x, where every single x value will be equal to the y value. So you can see here that if x is 2, then on the line y will also be 2. If x is 4, on the line y is also equal to 4. So this is a line that you all should know. The line y is equal to x splits the Cartesian plane exactly in half, an exact 45-degree angle. That is the line y is equal to x. Right? But we can see that we have all of these equations that give us straight lines. Notice Right? Well, I'll give you all this notice after. Right? But notice that no matter what the equation is, all of the powers in the equation, we ain't mess with the powers. We ain't mess with the powers at all. We ain't talking about no x squared and y squared. The minute you start to mess with the powers, it's not a straight line anymore. Yeah. So right now we're talking about straight lines. So the power of x and y will always be 1 when you're talking about straight lines. Right? So you can see this is an example here. When we did the math, we got these 2 points, 0, -2, and 2, -6. So you can see that based on the points that we get will tell us how to actually draw the graph. You know, it will tell us, you know, how do we draw these number lines so that I could get the negative points there as well. So you work on your points first. You keep that in mind because you don't want to be having huge values for x. So you don't want to choose x is 17 or x is 23. You don't want to choose that. You want to keep simple, small numbers so your graph will be simple. You can see this is the graph y is equal to -3x plus 4. I want you to notice something. Sometimes you just have a negative value in front of x. And the graph will be facing like this. Or sometimes you might have a positive value in front of x. Right? Sorry, x, this is a 3. And the graph will be facing like this. So we will talk more about this concept today. Today we're talking about gradient and them kind of thing. So this is another example here, and last class we just did tons of examples, right? So we have here, you could see the number in front of x is positive and the line end up being sloped this way, right? We found 2 very simple points, yeah? Notice something. All of the lines that we were looking at, right? These are essentially all of the lines that we were looking at. And you'll notice that they are all very similar. They all have a x value and a y value, and the x and the y value is to the power of 1. Right? So these are the graphs that we were looking at. Right? And now we're going to talk about, well, it have a way that you could just look at an equation and you could tell what the graph is going to look like. Right? So it have a way you could just look. You don't have to plot no points and things. You could just watch the equation and you could see what the graph is going to look like just by looking at it. And that's what we're going to talk about today. So we're starting off with the general equation of a line. So the equation of a line. Right? And we're talking about the general equation of any line. All of these lines that we had looked at in the last class and we drew them. Yeah, we plot the 2 points for each one and we draw each one. Right? But all of these lines, the general equation of any line takes a special form. So it takes this form. Y is equal to mx plus c. That is the special form that all lines take. You must know this form. Mx, that is a number m that is being multiplied by x. So the number that is multiplied by x, we calling that m. And then you have a number that is adding to the x. We call that c. These 2 numbers here have very special roles to play. The number m, which is the number that is multiplied by x, that number is actually the gradient of the line. The gradient being how steep is the line. Is the line this steep, or is it this steep? Or what if it's facing in the other direction? You know, so how steep is the line depends on this number m. M is the gradient. We will see that just now, right? The other number here, which is c. C is the intercept on the y-axis, the y-intercept. So you know you have your y-axis here, and you know you have your x-axis here. Whenever you draw a line, that line will be cutting the y-axis at a certain point. That point where the line cuts the y-axis, that point is C. That is the number C. So once you know what these two things do, once you know what that M represents the gradient of the line, right, and C represents the y-intercept where the line is cutting the y-axis, then you could easily look at a graph, look at an equation, and just sketch the graph and tell exactly how the graph is going to look. Right? So we will see that just now, but check this out. These are the lines that we were doing here. Now it's time for me to call some names, right? State the gradient M and the y-intercept C for all of these lines. So for each one of these lines, I want to know what the gradient M is, and I want to know what the y-intercept C is. So let me come on this little column here now. I will say the first one, y is equal to x plus 3. This is of the general form, y is equal to mx plus c. Could anybody tell me what is m in this equation? What is the number that represents m? I guess it's going to be a long class. What? Yes. M is the number that is in front of x. And so if it have no number in front of x, then that number is 1. It can't be 0 because 0 multiplied by x is 0. So it wouldn't have a x. So it have to be 1. So in this case, m is 1. What is c? Anybody else? I guess we're gonna be here all night. Thank you very much, Zara. We could see c is 3. So what does that automatically tell us? That tells us that this line is going to be cutting the y-axis at the point 3. Yeah, that is what that tells us. Yeah, let me take a look at the next equation. Y is equal to 2x minus 1. All right, so I'm gonna call a name, and you had to tell me what m is and what c is. Right? So the name I will call is Sabira. Sabira, what is m and what is c in this equation? Right? So m here is a positive 2. Yes, you do have to consider the signs. And you can see this c here is a minus 1. So that means that this equation will cut the y-axis below the 0. Right? We have the next one. Y is equal to 2x plus 1. So what is m and what is c in this equation? Let me show you. Y is equal to negative 2x minus 2. Let's look at this one here. Y is equal to negative 3x plus 4. Let me see. And this is the hardest one, right? We have the line y is equal to x. And yes, it is of the form mx plus c. So what is m and what is c in this equation here? Anybody? Where is it, Kayla? Yeah, so if c was 1, right? So if c was 1, it would have plus 1, right? Amir, well, Amir, I don't know if you know what we're talking about. Jeremy, what do you think is m and c in this equation? M is 1, C is 0. Yeah? So because C is 0 means I don't need to write anything. Yeah? Notice that C is 0. So that means that this equation will cut the y-axis at 0. And let me look back and see all of those things that we were drawing in the last class. This first one here, right, was y is equal to x plus 3. So you're seeing that c is plus 3. C is where the line does cut the y-axis. So you're seeing it cutting the y-axis at 3. Let me look at this line. This line is y is equal to x. So in this case, c is equal to 0. Yeah? It have no c. And so we could see that this line cuts the y-axis at 0. It does have a c. C is 0. That is where this line cutting the y-axis. Look at this one. C here is minus 2. So the line is cutting the axis, the y-axis, which is the vertical axis, at minus 2. Look at this one. C is equal to 4. And you can see that the line cutting the y-axis up here at 4. Look at this one. C is equal to minus 1. And we didn't draw this line very good at all. Yeah. Really and truly, when you draw a line, you want to see where it has cut the y-axis. So we didn't do a good job with this line. But if we had continued this line, you would have seen that it would have cut the y-axis at negative 1, just like the equation saying there. Usually when you're drawing a line, you do want to see where it cut in the y-axis. So we were talking about C, which is where it cuts the y-axis. And you could just look at the equation now and you could tell where that line is going to cut the y-axis. Yeah. So now you could almost look at the equation and draw the line. Let's talk about m a little bit. The gradient m, right? When m is positive, your line is going to be facing this direction. Yeah, it's going to be slanted this way. If m is negative, your line is going to be slanted this way. Right, so once m is positive, your line gonna be sloping like this. Once m is negative, your line gonna be sloping like this. And so, let me check back all of the graphs that we saw last class. So you can see last class, m is positive. M is positive 1, so the line sloping so. So now you can see in this case, we have the line y is equal to x. M is positive, and so the line sloping that way. Right? Look, in this case, we have m is negative 2. So m is negative, the line sloping like this. Right? So you can see in this case again, m is -3, so the line sloping this way. So now you can see here that 2 is a positive, so the line slopes this way. So now we can actually look at an equation. We could look at these equations here now, and we could actually sketch them, right? So for example, just by looking at this equation, oh crap, come on man, x plus 3, I could sketch this. I could sketch this and I could immediately say y, x. I could immediately say, well, all right, so it's a positive gradient, it's gonna be sloping so, and it's gonna be cutting at +3. So if this is +3, the line going to look like this. Yeah. Or what about this one here? Right? I could say, well, all right, y, ooh, look, this line cutting at -2. So if this is -2 here, then this will be the x-axis. And this line gonna be looking like this, is what this line is going to be looking like, because m is negative as well. So it's sloping negatively, and it have that -2 cutting the y-axis. So imagine how helpful it is that you could now look at an equation and you could just sketch it, and that will tell you, well, hey, when I draw in this graph, I would want to have this section of the graph, the negative part of the graph. You don't really want much of the positive because it have nothing there. So just by looking at an equation, we could actually sketch this thing. So we're talking about sketching here, and you can see that these are the very same equations that we did in the last class, and we are just going to sketch the equations by just looking at them, right? So you can see that I have this and this. You can tell that I'm going to be cutting at +3, and that the line gonna be sloping this way. Now it's just a sketch. You're not going to be exact as to how steep the line sloping, right? It's just a sketch. Yeah, that's the sketch. This is y and this is x here, right? So if we look at this one here, you could see, and we should probably make one more note. One more note. So let me just take one more note. The greater the value of m, the steeper the line will be. So you can see in this case here, this is y, this is x. The line going to be cutting the y-axis at +1, which is down here, but I will draw the line a little bit steeper because the number is greater. So I'll draw it a little bit steeper so that I know it'll be a little steeper than this one, right? So the greater the value of m is, the more steep the line will be. In this case here, I'm seeing that I have a +4 from a y-axis. So the y-axis is a +4 here, but a -3, that's not very steep at all. So this line will be looking like this. Right? This is the y, and this is the x. Right? So you are supposed to be able to look at an equation and sketch the line and just have an idea of what the line looks like. So we have this one here. Well, I'm seeing that it's gonna cut at -1 on the y-axis, right? So that means that when I draw my y-axis, it's gonna cut at -1. So that means the x-axis gonna be here, and the line will look probably like this. Oh, that's horrible. It's supposed to be a straight line like this. That is what that line gonna look like. And we already looked at this line. This line will be cutting. Y is -2, so I'll put -2 down here. So that means here could be 0. So this will be my x-axis. And I can see this will be the y-axis. This line has a negative gradient, so it's going to look like this. So we could just look at an equation now and just know, just from looking at it, what a line is supposed to look like. And of course, this is going to cut the y at 0, and we need to know this line. This is an important line to know. So it's cutting the y-axis at 0, and it has a gradient of 1. That gradient of 1 is pretty much a 45-degree gradient. So it kind of cutting the axis in half then. So we're gonna talk more about gradient now. So the gradient M. We're gonna talk about parallel lines. And we can see that two lines are parallel when they have the same gradient. Yeah. Also note that parallel lines will never meet, right? So I have two lines here. You can see the green line is the line 2x plus 1. So you can see that it cutting the y-axis at +1. Yeah. You can see that I have this line, y is equal to 2x minus 1. So it cutting the y-axis at -1. They both have a gradient of 2. So once two lines have the same m value, then they will be parallel. So you could look at two equations now, and you could tell if those two equations are parallel or not, right? Just by looking at the m value. Once the m value is the same, then you have parallel lines. Let me hear done it or question. Right, so when you see two lines are parallel, now you see this parallel thing, this is coming for your exam. It is. Yeah. For coordinate geometry, they will ask you two things. They'll ask you parallel lines. How do you know two lines are parallel? When the m is the same in both lines. Right, the number that is multiplied by x, that number is m. That is the gradient. Right? The other thing that they will question you about is perpendicular lines. And I hope that you all could read that red on the black as well, right? But perpendicular lines, if we multiply the gradients of two perpendicular lines. Now, no matter how much I teach this, people just still get tied up with it. So this is a teeth head, just letting you know. This gonna teeth your head, right? So just pay special attention. If we multiply the gradients of two perpendicular lines, the answer will always be -1. Answer will always be -1. So I have two lines here. This first line is -1/2 x plus 1. So you could tell that m, the green line, m is -1/2. Right? -1/2 x plus 1 means it cutting at y is 1. So I have the line negative a half plus 1. Then I have the white line, which is the line 2x plus 1, right? So, so in this case, m is 2. So for this line, the white line, m is 2. And for the green line, m is negative a half. So the question will ask you to show that these two lines are perpendicular. They are at 90 degrees. How could we tell that? Well, you just take the gradient of the first line, let's call that m1, and then we have the gradient of the second line, let's call that m2. All you need to do is multiply the two gradients, m1 multiplied by m2. So that will be 2 multiplied by negative a half. And if you get the answer to be minus 1, well, then the lines are perpendicular. So when you have perpendicular lines, lines that are 90 degrees to each other, perpendicular lines, how do you tell if it's perpendicular? All you have to do is take the gradient of one line and multiply it by the gradient of the other line. And you are hoping that you get minus 1. If you get minus 1, then they're perpendicular. If you don't get minus 1, then they are not perpendicular. Right? So if we multiply the gradients of two perpendicular lines, the answer will always be minus 1. Amir, you following with us so far, all of this stuff?
Yes.
All right. Amir, do you understand how to tell if two lines are perpendicular? All right. Do you understand how to tell if two lines are parallel? Very good. Look, I'm going to look at the parallel again for Amir and Naima. Right. Earlier, I know all you probably have homework and all kind of thing. We will keep today short because I know all you have work to do. But don't slack on this, because when we only doing this once. When we finish do this, we done with it. Right? So don't slack on it. Now, parallel and perpendicular, as I said, they are coming in your exam. For sure. For sure. They love to ask these two questions, right? And Samaya, you seem to have missed a lot, eh? Samaya, I don't know what it is. I don't know what it is you went and do, but guys, this is not the class where you had to go and get water or you go to the bathroom. No. This is the class where you get your water before class and you go to the bathroom before class. That is the class that this is. Because you go to the water, you go for water, you go to the bathroom, you're missing out. You're missing out. Samaya, you miss out on parallel lines and perpendicular lines. Yeah. So I don't know what. But now let me see who is who, right? We have these three lines form a right-angled triangle. Let me just erase these little red things here. I had a minus here. And I had a 2x here. Was it a minus and a 2 just now? Yeah, it is. It is. A minus x and a 2x here. Right. These three lines form a right-angled triangle. So we have three lines here. Y is equal to x plus 2. Y is equal to minus x plus 2. Right? Y is equal to x plus 2. That is equation 1. Y is equal to minus x plus 2. That is equation 2. Y is equal to 2x minus 3. That is equation 3. So we have three lines here. Right? You had to show, because if it is a right-angled triangle, right? A right-angled triangle means that two of the lines have to be perpendicular. Can anybody look at the equations and tell me just by looking which of those two lines are perpendicular?
1 and 2.
Nice. We can see that there. So immediately using this m1 times m2 is equal to minus 1. When you multiply the gradients, show which of the two lines form a right angle, right? So for number 1, we could see that this line, M is 1. We could see here that this line, M, is negative 1. Let me call this M1, let me call this M2, and let me call this M3. We can see M is 2 in that case, right? And so, we could see that if we take the first two of them, right, these two equations, M1 and M2, and we multiply those two, M1 multiplied by M2, the first two equations, that is 1 multiplied by negative 1, the answer there is negative 1. So therefore, equation 1 is perpendicular to equation 2. On a single graph paper, draw all three lines to show a triangle. And from the graph paper, state the points where the lines intersect. That is the vertices of the triangle. So here is what, right? We go finish class early today, right? Ooh, I wonder if we should, boy. I know it's a Tuesday now, so we go, I wonder, boy. I wonder if we should finish early. All right, we can't finish early because we just have horizontal lines and vertical lines to do again. That is all we had to do again. Horizontal lines and vertical lines, right? That is all we had to do. So we will finish early today, right? But I want Ollie to do this question now. And I want you guys to do it on your own. I already did number 1 for you. So number 1 here, you could see that equation 1 and equation 2, these two here are perpendicular. So they will give you your perpendicular lines, right? What you have to do is what we did in the last class. So you're supposed to be able to do it on your own, right? This will be the only question for the day that I will let you do on your own, right? After this question, we just had to do one little note on horizontal lines, one little note on vertical lines, and then that is it. So maybe we could be out of here by 6:30, right? But I want you guys to do this now. And how will I know that you all did it? Well, what you have to do is you have to draw these 3 lines. So that means draw on a single graph paper, not sketch, draw. So that means you had to find your 2 points for each line and draw the lines. When you draw the lines and on a graph paper, number 3 is to state the vertices of the triangles. So what I will do, how I will know that you actually did it or not, is I will ask you what you got for the vertices of the triangle. That is, when you have your graph, let me just say you draw one line, and we can actually sketch it. This is the line y is equal to x plus 2. So the first equation, gonna cut a 2 there, and it have a positive thing, so it's gonna look like this. The second equation, minus x plus 2. So it cutting at 2 here, but it's going to look like this. And we know that these two are perpendicular, right? It's supposed to be cutting at 2. And we know that they are perpendicular, so this will be a right angle, right? And then we have 2x minus 3. So this next line is going to be cutting at minus 3 down here. And 2x means it's going to be coming so. Right? So you can see here that this is the right angle triangle. This is what your right angle triangle should look like. This will be the right angle here, and I want you to tell me using your graph, what are these points? This point, and this point. You might see it in red a little better. This point, and this point. So I want you guys, I find that all you're sleeping today. I find that all you're not paying attention and all you be right back and all kind of thing. So now all you had to do something for me. And this question is what you have to do for me. You have to do it right now. I'll give you 5 minutes. Then I will call some names and I want to know what are the vertices that you got for your triangle. This is the only question I'll punish all you with tonight. Right? The only question. After this question, we're just gonna take 2 quick notes and then we're done for the night. Right? But take 5 minutes, do this question. Now type done it when you're done it. This is graph paper time now. So let me see what we're gonna do here now. We had to draw these 3 on our graph. And I could done see what I want my graph to look like from the sketch. I could done see that I need a little bit of the negative portion, right? But most of my triangle will be in the positive portion. So I'll need up to minus 3. So minus 3, just now. I'll need up to minus 3, right? So we have minus 3, I'll put minus 3 on the bottom, minus 3 here. So minus 3, minus 2, minus 1, so this will be 0 here. Right? So I'll put my 0, my x-axis over there. I'll use the double arrow line because your x-axis is supposed to have arrows on it. And then my x-axis, maybe I might need, I don't really need much of this side, so I might come like right here. And you could imagine, you could tell that just from the sketches. So you see how important it is to have your sketch or be able to know how to sketch. Because I sketched the 3 lines and I could tell just from the sketch how I want to draw my my axes, right? So this will be -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7. I hope, because I'm seeing up here that this is very, very high up there. So I hope my graph big enough to hold the whole thing. 1, 2, 3, 4, 5, 6. So we gonna see how big the graph gonna end up being. The first point, the first line is the line y is equal to x plus 2. So equation 1, y is equal to x plus 2. To draw any line, I need 2 points. So when x, let me go when x is 0, y is going to be 2. So if x is 0, y gonna be 2, right? Let me go when y is 0. When y is 0, x is going to be minus 2. I don't have minus 2 on my graph, so I wouldn't do that. So let me go when x is 0, let me go when x is 5. When x is 5, y going to be 7. So I have my 2.02 and 5, 7. So let me draw that. I will do this line in blue, right? So I have the point 0, 2. So 0 on the x, 2 on the y. That is that point there. 0, 2. And then you have the point 5, 7. So 5, 7 is up here. 5, 7. Almost off the graph. So now I will join the 2 points. And I will do it using a double arrow here. Right, so this line is the line y is equal to x plus 2. Alright, let me look at the next line. The next line I could see here, I better choose positive values for x, right? So the next line I see in here is y is equal to minus x plus 2. So number 2. Y is equal to negative x plus 2. I just need 2 points. So my 2 points, let me just say when x is 0, y will be 2 again, right? So it's the same point 0, 2. Now let me check when x is 3. Y is going to be, if x is 3, that'll be minus 3 plus 2, which is minus 1. So when x is 3, y is going to be minus 1. So that is 3 minus 1. So let's draw this one now, and I'll do this one in green. So 0, 2 is already here. And then the next point is 3 minus 1, which is here. So now I will draw this line. This line will go that way. And you had to draw it straight across your graph. So, we know that these are the two that are perpendicular. So this is going to be my right angle. That is a right angle there. Now let me look at the third line, line number 3. 2x minus 3. So y is equal to 2x minus 3. I see Jaden, like you're real in and out, boy. So 2 points is all I need. When x is 0, that means this whole thing gone. So y will be minus 3. So the first point is 0 minus 3. And when x is, alright, well I know this line gonna go so let me go when x is 5, 2 is 10 minus 3. When x is 5, y is 5 2s are 10 minus 3 is 7. So I have another point here, 5, 7. So it looked like I'm just big enough on my graph. Thankfully, I will draw this line in red. So I have the point 5, 7 here, that's already there. And then I have the point 0 minus 3, which is here. Oh, what's up with police, boy? Alright, and so, I didn't label this line. So this is the line y is equal to 2x minus 3. And this is the line y is equal to minus x plus 2. And now I could look for my vertices. I could see that one of the vertices of the triangle is the point 02. Another one of the vertices is the point 57. And we have this vertex here that might be hard for us, right? Because if this is 1.2468. So let me call that 1.7. Because if you notice, every one of these small lines is 0.2. So if this is 1, this is 1.2, 0.4, 0.6, 0.8, and that'll be 2. Right? So this is between 0.6 and 0.8, so we'll call it 1.7. So yes, Sarah, you turned out to be right. Right? 1.7. And this on the y-axis is 0.2, 0.3, maybe. Yeah, 0.2. It's not 0.2 and it's not 0.4. So it's between 0.2 and 0.4. So that we call it 0.3. So yeah, that third vertex was a little bit tough for us to read off of the graph. But it just goes to show how well you have to know the divisions of your graph. And why it's important to have the equal division on both sides. Right? So I'll just leave this up for a few, like for 30 seconds to a minute, for anybody who write in, or for anybody who just want to jot it down. And then we just have 2 short notes to take, and we'll call that a day today. Anaya, you understand this question?
Yes, sir.
All right, good. Naima, I saw that you almost got it. You just had problems reading that third point, right? All right, so I'm just going to give you all 30 seconds again. And I'll just explain it one more time. Because I'm seeing that the thing between 1 and 2. So I immediately thinking, well, all right, where's the x value here? If it's between 1 and 2, then what is it? Will it be 1.5? You know, and how do I measure that? Well, I have to check and see each line. 1, 2, 3, 4, 5. 5 spaces between 1 and 2, right? So that means that I could take each one as 0.2. So if this is 1, then this first line will be 1.2, 1.4, 1.6, 1.8, and then I reach by 2. So I could tell that each one of the small lines does represent 0.2, right? So do you understand that, Cherise?
Yes, sir.
All right, and I could see here that this vertex here is not exactly on the 0.6, and it's not exactly on the 0.8. It's between the 0.6 and the 0.8, so I just estimate it at 1.7. Yeah, and I could tell here that this line is also, in terms of the y-axis, it's not on the 0.2, the point, and it's not on the 0.4. Well, not on my graph. Sarah put the 0.4. I will put the 0.3. And of course, for something like this, there will be a margin of error. So, you know, if you put 1.8 and 0.4, you can still get it correct, you know. Narcissistic liar, right? So I did lie. It's not the only question. We do have one more question here. And this is the question. We are not going to do the question now. This question is for you for homework, right? On a single graph sheet, draw these lines here. We have the line y is equal to x plus 1, y is equal to minus x plus 1, y is equal to x minus 1, y is equal to minus x plus 3, right? So find the 2 points for each one of the lines. On a single graph sheet, plot the points, draw the lines, label the points, the lines, and the axis. Are any of the lines perpendicular? Show working to show, to prove that they are perpendicular. I could watch these lines and I could immediately tell which lines are perpendicular and which lines are parallel. I could tell that this line and this line are both parallel. I could tell that this line and this line are both parallel. I could tell that this line is perpendicular to this one, and I could tell that this line is perpendicular to this one. I could just tell that just by looking at the equations. I could also just look at the equations and I could sketch what the four lines are supposed to look like and have an idea of what my graph is supposed to look like, right? Are any of the lines parallel? Show working to prove. Yeah, so you have to show the working to show that they are parallel. What shape do the lines form on the graph? Well, of course, I have more experience than you, so I could just look at the equations and I could tell what shape that is. But of course, if you can't, then just draw it and you'll find out. So I'll give you a couple of, a minute to just write down this question. You just have to write down the question. You will do this for homework, right? So take a minute, write down this question, and then we just have 2 notes to take. They're not just random equations, no. They all have a form, a very special form. All of the equations are actually of the form y is equal to mx plus c, where m is the gradient and c is the y-intercept, right? When m, the gradient is positive, we get a line sloping this way. When m, the gradient is negative, we get a line sloping this way. And of course, the y-intercept is where the line cuts the y-axis. You could tell just by looking at the equation. The problem is, what about horizontal lines and vertical lines? Yeah, lines that are perfectly horizontal. You could tell that lines that are perfectly horizontal will have a gradient of 0. And theoretically, lines that are perfectly vertical will have a gradient of infinity. Yeah? These numbers here will only account for a slant line. So this equation here will only work for slant lines. When you're talking about parallel lines, not parallel lines, when you're talking about horizontal lines and vertical lines, the equation is just a little bit different. Oh crap. So horizontal lines have no gradient. That is, m is 0. Right? So if you have the equation of a line, y is equal to mx plus c, and m is 0, well then you'll have y is equal to 0 times x plus c. So obviously 0 times x, the entire whole of x gone there. It have no x no more. So you will just be left with y is equal to c, which is just a number. Right? So we have an example here. This is a horizontal line. Right? The red line, and I'm sorry for all of the points that I've jotted all over, but the red line, this is the line y is equal to 3. Right? So this red line is the line y is equal to 3. That means that it will cut the y-axis at 3, and it have no m, it have no x. So it will just be a horizontal line. So the line, when you just see y is equal to 3 alone, that is a horizontal line. You have to know the difference. This is one thing that has messed up students, is the difference between a horizontal and a vertical line. When you see y is equal to a number, notice that no matter what the x value is, the y value is always the same. So this is the line, the horizontal line, y is equal to 3 is a line. If you look at all of the x values here, this is when x is 1, guess what? Y is 3. When x is 2, guess what? Y is 3. When x is 3, guess what? Y is 3. When x is 4, guess what? Y is 3. Y will always be 3 to infinity. X will change. Right? X could be anything. X could be any number. It doesn't matter. Y will always be 3. And so this is the line, y is equal to 3. Let me hear some donuts for this. Let me see how fast I want to leave. Donuts or questions, please. All right, anybody didn't done it, moving on. So we see here that when we have a horizontal line, that will always take the form y is equal to something, right? So just now, let me just, sorry about all of this scrappy stuff. If we had a y and an x-axis, then you could see that, if this is 7, right, that horizontal line that passing through, that will be the line y is equal to 7. Or let me just say we have 5. So the horizontal line that passing through here will be the line y is equal to 5. And of course, for both of these, m is 0, which means they will be parallel. They have the same m. I could even have a line down here. Let me just say by -1. So I'll have a horizontal line here. This is the line y is equal to -1. But what about the x-axis? This is important. Right? The x-axis is a horizontal line cutting at the point y is 0. So the equation of the x-axis is the line y is equal to 0. So let's make a note of that real fast, right? The x-axis is a horizontal line cutting the y-axis at y is equal to 0. Therefore, the equation of the x-axis is y is equal to 0. That's an important point. Please don't forget that. That point comes in handy. 30 seconds, and then we have one more note to take, and then that is it. Aidan and Ria, I'm so very sorry for keeping you all back. I know I said 7:30. I just finishing up with these kids here. So just give me 5 more minutes, and then we could talk, right? So I'm very, very sorry about keeping you all back. Nice. Last one we're gonna talk about is vertical lines. All right. So this is just an idea here. Vertical lines now, right? So this is the last one. A vertical line. Vertical lines have a gradient of m is infinity. That is, the gradient is undefined. We don't know what the gradient of a vertical line is. It's so steep. Vertical lines take the form x is equal to a number, where x is equal to a, where a is a number, right? So if we notice here, this is the line x is equal to 3. Right? So when you see x is equal to a number, you had to know that that is a vertical line. And students get this mixed up all the time. Yeah? When you see y equals a number, that is horizontal. When you see x equals a number, that is vertical. You could see here that this is the line x is equal to 3. It's a vertical line, right? It cuts the x-axis at 3. Notice, no matter what y is, if the y value is 1, right, x gonna be 3. If the y value is 2, x is 3. If the y value is 3, x is 3. If the y value is 4, x is 3. If the y value is 5, no matter what y is, x is always 3. So this is the vertical line, x is equal to 3. We just have one line again to write and then we're done. One line again to write and then we're done. So let me know when you're done it with this. Denicia, how you doing? Hello, Denicia. Denicia, you missed most of my class. You all right? Well, thank you for coming to the class. You missed most of it, but thankfully these sessions are recorded. So I hope that you'll go and check out the class videos for coordinate geometry, right? I'll just come on this side. Oh yeah, look, I already have it here. The y-axis is the vertical line x is equal to 0. So you see, this y-axis is a vertical line. No matter what point I put on this line, this point here is 0 on the x, 1 on the y. This point here is 0 on the x, 5 on the y. This point here is 0 on the x, 10 on the y. So no matter what the y value is, on the y-axis, the x value will always be 0. So the y-axis is the vertical line x is equal to 0. All right, guys, that is it for today. You do have one question to take a look at for next class. Next class, we continuing with coordinate geometry. We'll be finishing up with coordinate geometry in the next class. 2 more classes again. One class to finish coordinate geometry, and then another class to just do past paper questions on coordinate geometry. Alright, so by next Tuesday, we'll be done with coordinate geometry, moving on. But next class, Saturday, is going to be a heavy algebra class. These past 2 classes, we learned how to draw a line using 2 points. But in the next class, we had to work backwards. Yeah, we actually have to we will be given the 2 points, and you have to find what the line is, what the equation of the line is. So in this class, we had the equation of the line, and we had to find the 2 points to draw the line. In the next class, we will be given the 2 points, and we'll have to use those 2 points to find what the equation of the line is. Saturday's class will not be a drawing class, really. We wouldn't have much graphs to draw, but we will have some heavy algebra to deal with. So please don't miss Saturday, because the algebra gonna be a bit heavy, so you're going to want to be here to see it, right? Unless anybody has any questions, that's it for today. Have a good night, everybody, and I'll see you all on Saturday at 3. Bye.
Bye, sir. Have a good night.
You too.